Okay, so get this. Picture this. Like you could freeze something just by looking at it. Sounds kind of wild, right? Like something out of,
Yeah.
like a superpower or something.
Yeah, like straight out of a comic book.
Exactly. But that's what we're diving into today. It's a real head-scratcher in the world of quantum physics. It's called the quantum Zeno effect.
And it's every bit as weird as it sounds.
It really is. So basically, we're talking about the idea that just by observing something, you might actually be stopping it from changing.
It's like hitting a pause button on reality itself.
I know, right? It's a lot to wrap your head around. But that's what we're here for, to unpack this whole thing and hopefully make it, somewhat understandable.
We're going to try and break it down as simply as possible.
Exact.
But fair warning, we're dealing with some pretty mind-bending stuff here.
We are. So to even begin to understand the quantum Zeno effect, we kind of have to start with another, like a really key concept in quantum mechanics. It's called superposition.
Right, because without superposition, the Zeno effect doesn't really make sense.
Exactly. Okay, so imagine flipping a coin. You flip it up in the air, right?
Yeah.
And while it's spinning, before it lands, it's kind of both heads and tails at the same time. Or at least we don't know which one it is yet.
Exactly. It's in this uncertain state.
Right. And quantum particles, they kind of do the same thing, don't they?
Yeah, that's actually a really good analogy. In the quantum world, particles can exist in multiple states at the same time, just like that spinning coin.
So it's not just that we don't know what state they're in.
Right. It's that they're actually in all of those states simultaneously.
Whoa.
Until we measure them, that is.
Until we force them to choose.
Exactly. And that act of measurement, of observation, that's where things get really interesting with the quantum Zeno effect.
Okay, so this is where the Zeno part comes in. And I have to admit, this is where I really started to get lost. So
Yeah, it gets a little tricky here.
it does. But the article we read, it used this analogy about a prisoner and a guard.
Mm.
And that really helped me understand it, actually.
Oh, yeah. That's a classic one.
Yeah. So picture this. You've got a prisoner, right?
Mm.
And a guard who is supposed to be keeping an eye on them. Now, if the guard is constantly checking on the prisoner,
Like every 2 seconds, looking in on them?
yeah, like nonstop surveillance,
Yeah.
it's going to be pretty much impossible for that prisoner to escape.
Exactly. Every time the prisoner tries to make a move, the guard's right there to stop them.
Right. But if the guard only checks on the prisoner, like every once in a while, then the prisoner has a much better chance of making a break for it, right?
Yeah, absolutely. They've got those little windows of opportunity where they can try to escape.
Exactly. And that's kind of similar to what happens with the quantum Zeno effect, right? It's like the act of observing the particle is like the guard constantly checking on the prisoner.
Precisely. Every time you observe the particle, it's like you're resetting it back to its initial state.
So it's like you're preventing it from changing by constantly observing it.
In a way, yes. It's like you're freezing it in its current state because you keep interrupting its natural evolution.
Wow. Okay. I think I'm starting to get it now.
Uh,
But how do we actually know this is real? Like, has anyone actually seen this effect in action? So this isn't just some, like, theoretical idea, is it? Scientists have actually tested this whole quantum Zeno effect thing.
They have. It's not just some thought experiment. There have been actual experiments done.
Mm-hmm.
And they really show how strange and real this effect is.
So, like, what kind of experiments are we talking about here?
Well, one example is they trapped a bunch of particles, and they basically kept measuring their state over and over.
Like, nonstop measuring.
Yeah, pretty much.
And what happened?
They found that the more they measured the particles, the less likely those particles were to change their state. It was like the act of observation was holding them in place.
That's wild. Okay, so it seems like this observation thing, it's like, it's got some real power to it, but it's not, like, it can't freeze everything in time, right?
You're right, it's not all powerful.
Because I remember the article mentioned something about radioactive decay
Yeah.
and how that's kind of an exception to this whole Zeno effect thing.
Yeah, that's a really good point.
Like, you could stare at a radioactive atom all day long, but it's not going to stop it from decaying, right?
Exactly. And that's because radioactive decay, it operates under a different set of rules.
Okay, so how come radioactive decay, how come that's different?
Well, it comes down to the nature of the process itself. See, with the quantum Zeno effect, we've been talking about systems that have a few specific states they can be in.
Right, like that spinning coin analogy.
Right. Heads or tails. But radioactive decay, it's not that simple. It doesn't follow those same rules.
Okay, so it's not just a flip of a coin, so to speak.
Exactly. The decay process, it's governed by forces inside the atom's nucleus. And observing it, like looking at it, that doesn't change those forces.
So it's like those forces, they're going to do their thing,
Yeah.
regardless of whether or not we're watching.
Exactly. It's like you can try to stop a storm by staring at it, but it's not going to work.
Right. So even quantum weirdness has its limits.
It seems that way, yeah.
But I have to say, even with those limits,
Hmm.
this whole idea that just by looking at something, we might be able to change it.
It's pretty
It
mind-blowing.
really is. Like, it makes you wonder about, about what else is out there. What other strange things we might discover about the universe.
Absolutely. It really makes you question everything you thought you knew about reality.
It's like we're just starting to scratch the surface of all this, right?
Yeah, absolutely. We've still got a lot to learn about the quantum Zeno effect and what it all means. Not just for science, but,
Maybe for us too.
yeah, like what does it mean for us as humans if just by looking at something, we can change it? Even if it's just at like a tiny quantum level.
It's a huge question, and it really makes you think about what is our role in all of this? Are we just observers, or are we actually shaping reality in ways we never even realized?
Right.
And, if we ever get to the point where we can actually control this effect, imagine the possibilities. Yeah, like what would you even do with that kind of power?
Exactly. If you could freeze anything in time just by looking at it, what would it be?
That's a good question. I mean, it's almost too big to even think about.
It kind of makes you rethink everything you thought you knew about time and choice and the universe.
It really does. Well, I think we've given our listeners a lot to chew on today,
Definitely. And hopefully spark some curiosity too.
for sure. So, to everyone listening out there, until next time, keep asking those big questions and never be afraid to dive deep into the mysteries of the universe.